Today we're going to continue with lesson 8.2, which is still multiplying and factoring. So our objectives today, we're going to multiply a monomial by a polynomial, and then we're going to factor out a GCF. So remember, when we're multiplying, we have to think about distributing that term on the outside to everything that's in parentheses. If there's a variable on the outside and the variable on the inside is the same, then we keep the variable and we add the exponents. So in this first one, 2x is getting multiplied by all three of those terms inside. So 2x, when I distribute that to the x squared, the 2 is going to stay 2, but now with the x is being multiplied, I keep the base. Technically, there's an exponent of a 1 on the outside. I'm adding the exponents. 2 plus 1 is 3. I'm going to bring down that subtraction sign, and now I'm going to repeat the process. That 2x is going to get multiplied by the 11x. Well, 2 times 11 is 22. The x's are going to get multiplied. So since they're both an x, I keep the base. There's technically an exponent inside as well. So the 1 on the outside and the 1 on the inside get added together. 1 plus 1 is 2. So that middle term is 22x squared. I'm going to bring down that addition sign. And now that 2x is going to get multiplied by the last term, which is 7. Well, 2 times 7 is 14. Because the 7 doesn't have any variables, the x on the outside is going to stay an x as far as my final answer goes. Because each of these are different terms, none of the exponents are the same, no like terms, I can't combine anything. The biggest exponent is first, then is the next biggest exponent, and then finally the x is the smallest exponent. So this is in the order that I want it. This is my answer. Now in problem number 2, x to the 5th is going to get distributed to negative x plus 4x squared. So x to the 5th gets multiplied by negative x. Once again, we add the exponents for the bases that are the same. So the negative out in front is going to have to stay a negative. X to the 5th times x to the 1st. You keep the x, you add the exponents, it becomes x to the 6th. I'm going to bring down that addition sign. The x to the 5th gets multiplied by the 4x squared. So since there's no number on the outside, the 4 is going to stay as it is. X to the 5th times x squared means I keep the x's and I add the exponents. 5 plus 2 is 7. Because this is not in standard form, because the 6 is an exponent that's smaller than the 7, I'm rearranging it. So I want that positive 4x to the 7th first, and then the negative x to the 6th second. So this would be my final answer. Next, they're asking us to factor. So when we factor, essentially what we're going to do is we are going to look for that GCF. Okay, so first and foremost, we look for the GCF. So that's why we practiced finding that greatest common factor yesterday. That's what we're going to still do today in order to factor. But after we're done looking for the GCF, we are going to put the GCF out front, and in the parentheses, put what is left over. Essentially, what we're going to do is we're going to turn it into a problem like we had when we multiplied. In problem number 1 and in problem number 2, we had something outside of parentheses and then something left over inside of parentheses. That's what we're doing here. Factoring is actually the opposite of distributing. I'm taking something out of those terms and then creating parentheses and putting whatever's left over. So let's start with number 1. If I have 2x squared plus 4x, I want to find a GCF. So as far as the 2x squared term goes, I can't break up the 2 any further. If you want, you can think of it as 1 times 2. And then x squared means that it's x times x. As far as then the second term, which is a 4x, I know that 4 can get broken up into 2 and 2, but I can't break that up any further. So 2 times 2 is a part of that, and then there is an x. Okay, so if we're finding a GCF, it means what is in common in the top row as there is in the bottom row. So I see a 1 on the top, but I don't see a 1 on the bottom. I see a 2 on the top, and I see a 2 on the bottom. So that means they have a 2 in common. That's a part of my GCF. I don't have any more numbers on the top, so I can't put any more numbers in my GCF. So as far as me determining what my GCF is, I know that they have 1, 2 in common, so I'm going to write 2 one time. If I keep going, I have an X on the top and I have an X on the bottom, so they have an X in common. If I keep going, there is another X on the top, but there's no more variables on the bottom. So it looks like the only variable they have in common is 1X. So my GCF is 2X. So there was my first step. We found our GCF. So I'm going to write 2X, and then in parentheses, now I'm going to have to put whatever was left over. So what I'm going to have in parentheses, if I go back to my original problem, I have a binomial. There's 2 terms here. That means I should have a binomial in the parentheses. Notice how there's an addition sign breaking up those 2 terms? So I know I'm going to have an addition sign breaking up those 2 terms. Since 2x squared was the first term, I'm looking at the top row, and whatever was not in common needs to go back in parentheses. Well, for me, it's whatever wasn't highlighted. I have a 1 and I have an x. When those get multiplied together, 1 times x, you can write 1x, or you could just write x. But that's what was left over in the top row. If I look at the bottom row, there's only one thing that isn't highlighted, that 2. So that missing 2 needs to go back into the parentheses. And this would be my answer. And if you want, you can verify that you did this correctly by noticing that there's nothing in common in parentheses between a 1x and a 2. And if I was to distribute that 2x, we should get back to what our original problem was. Let's try another one. If I have 5x squared minus 10, first thing that I'm going to do is I'm going to look for a GCF. The 5, I can't break that up any further. 5 is just 1 times 5. So with my 5x squared, I'm going to have 1 times 5. X squared means I'm going to have x times x. If I look at the second term, which is just 10, I can break that up. That's 2 times 5. I can't break those up any further, so 2 times 5. There's no variables. So between these 2 rows, I had to figure out what is in common. What's my GCF? I see a 1 on the top, but I don't see a 1 on the bottom. I see a 5 on the top, and I see a 5 on the bottom. So because there's 1 5 in common, I know that my GCF is going to have a 5. I see x is on the top, but I don't see any variables on the bottom. So there's not going to be any letters in common. So it looks like just the 5 is my GCF. So we put that GCF on the outside, and then in parentheses, we're going to put whatever was left over. In my original problem, I had 2 terms. I had a binomial with a subtraction sign in between them. So that means in my parentheses, I should have a binomial with a subtraction sign in between. If I go back to that first term of 5x squared, whatever is not highlighted needs to be multiplied and put back in the parentheses. So 1 times x times x. Well, that's going to give me a 1x squared. So that's what's left over that was not a part of that greatest common factor. If I look at the bottom row, what was the only thing that wasn't highlighted? A 2. And so this would be my factored answer. If we look at this third problem, we've got 12xy minus 6y. 12 can get broken up multiple ways. One of the ways is 4 times 3. 3 can't get broken up, but 4 can. That's 2 times 2. So because the 4 got broken up, I'm not including that. So if I'm thinking about 12xy, I know that my numbers are 2 times 2 times 3. Those are the numbers that multiply to get me 12. And then there's an x and there's a y. If I look at the 6, I can break that up into 2 times 3. So 6y is 2 times 3 times y. So let's start looking for what those two rows have in common. I see a 2 on the top and a 2 on the bottom. Even though there's another 2 on the top, I don't have another 2 on the bottom, so I can't highlight that second 2 on the top. But there's a 3 on the top as well as the bottom, and there's a y on both the top and the bottom. So because that's the case, anything that's highlighted gets multiplied together to become my GCF. So there's a 2 and there's a 3. So one pair of 2s and one pair of 3s and then a y. So if I multiply all that together, that tells me that my GCF is 6y. So 6y is going to go out in front of the parentheses, and now I have to put whatever's left over. So because my two terms right there are being broken up by a subtraction sign, I want two terms in parentheses being broken up by a subtraction sign. If I look at what I have left over in the top row, what is not highlighted is a 2 and an x. Well, 2 times x is 2x. If I look at the bottom row, everything is highlighted. So that means that I took everything out of the 6y. But remember, factoring is essentially the opposite of distributing. If I was to multiply that 6y to everything in parentheses, I should get back to what I started. So because that last term is 6y, but that's what I took out, what do I multiply 6y by in order to keep it the same? That would be the number 1. So anytime your GCF is one whole term, you have to put a 1 in its spot in order to keep the problem correct. And so this would be my answer. All right, one last problem here. We've got 30x squared plus 10x plus 5. So this time there are 3 terms. So I need to find the GCF between all 3 of these things. So start with the 30x squared. 30 can be broken up into many different ways. One of the ways would be 6 times 5. I can't break up the 5 any further, but 6 is 3 times 2. Now, because I broke up the 6, I am not including that. So the only numbers that are circled would be a 3, a 2, a 5. That multiplies to get 30. The x squared means that I want x times x. If I want to figure out then 10x, I can break up 10 into 2 times 5. So 2 times 5, and then there is an x with it. 5 is what we call a prime number. The only way to multiply to 5 is 1 times 5, and there's no variables there. So I'm going to use this to find my GCF. So this time I need to look at all 3 rows. So in the first row, I see a 3, but I don't see that in the second row. I don't see in the third row, so I can't highlight that. I see a 2 in the first row. I see a 2 in the second row, but I don't see a 2 in the third row, so I can't highlight that because not all 3 of them have a 2 in common. But I see a 5 on the top, in the middle, and on the bottom. So because they all had a 5 in common, that's a part of my GCF. While there's an x on the top and in the middle, there are no variables in the bottom row. So it looks like out of everything, I see 1 5 in common, so 5 is my GCF. So if 5 is my GCF, I need to go back and put whatever's left over in parentheses. Now, because there were 3 terms to begin with in this problem, I've got 2 subtraction signs. I need to keep addition. I need to keep 2 addition signs. So then I can keep that trinomial in the parentheses. So if I go back to the top row, there was a 2, a 3, an x, and an x. I'm multiplying those back together. 2 times 3 is 6. X times x is x squared. In the middle row, what wasn't highlighted? Well, 2 times x, so 2x. And then what wasn't highlighted in the last row? Well, a 1. And so this would be my answer. All right, I would suggest that you pause the video and try this checkpoint problem. Okay, so hopefully you noticed that if you broke down 11, 11 is just 1 times 11. So 1 times 11, and then there were 3 x's. 22 is 2 times 11. I can't break up that any further. So we'll have 2 times 11, and then there are 3 y's. So I'm looking for a GCF. What do those have in common? Well, there's a 1 on the top, but I don't see a 1 on the bottom. I see an 11 on both the top and the bottom. Because I only see it once in both of those rows, I write it 1 time. All of the variables on the top are x's. All the variables on the bottom are a y. So there's nothing else in common. 11 is the GCF. So then if 11 is the GCF, now in parentheses, we should have 2 different terms. Notice how there should be a subtraction sign in between them like our original problem. So what we need to do is go back to the top row, multiply 1 times x times x times x. So that's a 1x to the third power. Then I look at the bottom row and I multiply 2 times y times y times y is a 2y to the third power. And this is your answer.